Hello, good to see everybody again, or at least to be on the channel with everybody and to see a couple of you. uh, so yeah, today I'm going to talk about chapter 7, which was about exploratory data analysis. This is, I've said this for a couple of chapters now, but this is another one that's kind of really the meat of the book. This is what the rest of the book is about, basically. This chapter is kind of introducing everything that's coming. All right, and so I put together these learning, or actually I think my coworker put together these learning objectives. The first thing we're going to try to do is recognize the two types of questions that we'll tend to ask about our data, which is what type of variation occurs within my variables and what type of covariation occurs between my variables. And in doing that, we're going to explore the variation within our variables. And then we're going to deal with outliers and missing values in our data. We're going to explore covariation between the variables of our observations. And then we're going to recognize how models can be used to explore patterns in our data. Yeah. Oops. Did that? Oh, yes. So I put together a list of just some basic vocabulary that he went into, or I don't want to imply too much with the word basic there, but some important vocabulary that he goes into. So a variable, I've used that word a couple of times, the learning objectives. That's any quantity, quality, or property that you can measure. And measure is really fuzzy there because like someone's name is a variable. You're not really measuring their name per se, but you're logging it. The value would be the state of a variable when you measure it, and it can change, from, from observation to observation. So observation is a set of measurements made under similar conditions. The idea is you have one value for each variable. And then tabular data is observations of variables. And if it's tidy, that means that every observation is one row and every variable is one column. And then each cell within that is one value. I pointed out here because he doesn't really go into it, but a lot of times people are like, hey, is this data tidy? And it depends on somewhat on what you're trying to answer. Sometimes the definition of an observation, sometimes it might be all of the data about one location, let's say, or sometimes it might be all of the data about that location on a particular day. And so then you would have multiple rows for that location in that case. And both of those can be tidy depending on what you're trying to work with. But in general, tidy data is the thing that Hadley Wickham is known for. He wrote the tidy manifesto and about how important it is to get your data tidy before you can really do anything else with it. And just not just how important it is, but how useful it is. If you take the time to really think about, make your observations rows and your variables columns, everything else becomes easier from that. All right. So then the first thing we talk about within exploratory data analysis is variation, which is the tendency of values of a variable to change between measurements. And so it's basically how different are different measurements of this same variable. For a categorical variable, that's variables that can only take certain values, rather than a continuous variable can take any variable along some continuum. And generally, you can visualize categorical variables with bar charts or things like bar charts. And so he has an example here of a simple or a straightforward ggplot that is using the built-in diamonds data with the aesthetics, just X is cut, and then G on bar automatically puts bar plot with the Y is the count of that variable within the data. And so this is a nice quick way to visualize anything that's a categorical variable. I don't think he really specifically said it, but part of the idea is all of these things are useful things to do when you just are starting to look at a data set. Find all of your, first figure out which variables are continuous, which ones are categorical. Sometimes they might be coded as categorical, or they might be coded as continuous. You know, it might be coded as just a number, but really it can only be 1, 2, or 3. And so that's more like categorical. And so if you start doing this visualization, you can see what's actually going on in your data to help you figure out what questions are worth asking. All right, so next up we have continuous variables. That's anything that can take anything within a range, some ordered set of variable or values. A good way to visualize the variation for something like this is a histogram. And so we look at just kind of the baseline histogram. Let me make it actually fit on the screen. And the idea is you got, you're getting the diamonds data, the aesthetics. We just are saying that the X is the caret column, and then we just do a histogram. You can set that bin width. It's basically just how many values or what range of values go into each bin. And you get something like this. And we can see, oh, this here around 0.5 seems to be pretty important, or it's pretty common in carets. He also talks about geom-freq poly, frequency polygram, or polyline, I guess it is. It's not poly, whatever. Where it's this line that instead of so a histogram has columns, bins, and the only reason to do this other one is if you have data on top of each other, stacked bins can be hard to see. And so he shows us some code. I'm putting in a little reminder here that the percent greater than percent is the pipe that we talked about a couple of weeks ago, and just think of it as then, or as and then. And then also ggplot, we talked about week 1 or 2, that it uses plus to add things on. So you, in my trend of how to pronounce things as you're reading the code, think of that as with or and. And so we can say, okay, we were making this smaller data set that is smaller, gets diamonds, and then filter by caret less than 3. And then you take ggplot of that smaller data set with aesthetics of X is caret, and the color is cut, and he spells it OU. You can also spell it American style with just the O. I copy pasted, and so I got the OU. And then, and the geom-freq poly with bin width of 0.1. And so you can see that it's basically the same idea as columns. It's just on top of each other. So each of these peaks would be the top of a column. That's the general idea there. And then the big thing here is once you have these, or as you make these visualizations, the whole point is to start figuring out some questions. And so common questions for any of these visualizations, like I talked about, is which values are the most common. A question you might have is why? Why is that common? Is it something that you have to talk to an expert to figure out, or is it something that can, is in the data? Which values are rare can also be important, and why? And a good question to ask yourself is, is that surprising? Basically, maybe you thought that caret, for whatever reason, would be mostly 3 and above, and there's no 3 and above. So, I mean, that shouldn't surprise you if you know anything about this data set, but still, who knows? You might not know what to look for. And can you see any unusual patterns? Something here that we're kind of, well, I don't know. I don't see anything unusual there. There are little blips up and down, but it's pretty straightforward. Oh, and if it's only 2 values, sorry, there is a question in the chat from a while back that I didn't see. From Lucy, is it best to visualize the variation in a categorical variable with only 2 levels using a bar chart? If not, what's the chart to use? And Ryan said, well, yeah. So it could, I don't know of anything better than a bar chart even for two. Like a lot of times, um, it's still really, a bar chart is such a basic way to just quickly see the difference. Um, it can depend on the data somewhat, and a pie chart, um, pie charts get a lot of hate. Uh, a pie chart, I never really realized until working with ggplot is just a pie chart or a bar chart in polar coordinates. So all you have to do is add plus coord underscore polar to a bar chart and it becomes a pie chart. Um, the thing to do with pie charts is always make sure that your pie chart adds up to a total. So don't make a pie chart that is a bunch of like only somewhat related things, but for categorical variables within your data, that can work. And I can't remember the number cutoff I've seen, but low number of things in a pie chart. If there are 100 different values in your pie chart, it doesn't say anything. You can't see it. If you really want to see the difference between three variables that are almost the same, a bar chart's way better than a pie chart because it's hard to judge the exact sizes of wedges. But if all you're really trying to say is, like especially when there's two, actually, a pie chart can be great because it's kind of telling you what percent of the total is each one. And pie chart can actually work pretty well for that. So yeah, that would be my thoughts on categorical. A box chart, as in like a pie chart where it's a tree map would be another way. For not for two, but a tree map. Well, technically it can work for two, but tree map is the name where you are breaking it down into like boxes inside of boxes. I find them hard to read, but they can be good. I'm gonna go over to in a minute. I'm gonna send or point out a website of a guy who does amazing visualizations for Tidy Tuesday, and he does tutorials, and he's actually active sometimes on R4DS. So, I recommend actually the general thing about trying to figure out what works for visualization. I really still always recommend the Tidy Tuesday hashtag on Twitter. People make amazing visualizations. Sometimes they make like I've done some that are just kind of cool, but not particularly useful. And it can be useful to see that, to like really stop and think and ask the questions. You know, basically, is this visualization helping me answer questions and helping me figure out questions to ask? If not, try something else. There's all kinds of geoms in ggplot. There are other add-ons to ggplot. And you can try other things and see what helps. For example, like he goes into freak poly in the book, and I don't think I've ever made one of these. I don't think I've ever used these. I've used density. I've used violin plots. I've used box plots, which we're going to talk about later. I don't know that I've ever actually made a freak poly. I would end up just doing stacked histograms a lot, where you can do or ridge plots is another option that's from GG Ridges. There are lots of other things out there. And so it's good to kind of explore and see what works for you. All right, so the next thing he does is he shows us a value where when he does the histogram, you see these kind of peaks and then drops off, peaks and then drops off. And that kind of is making us wonder, what's going on there? Like what are the groupings? My instinct, anytime I see something like this, would be that those are the round values, and that's what people tend to log, or maybe your measurement instrument can only do, sometimes it can only do 1 or 0.5, and then or 1, 1.25, 1.5, 1.75, that kind of thing. It depends on what data you're looking at, but a lot of times that's why you will get these peaks, is just because they're not necessarily really peaks. Like it's not necessarily that they're really more common. It just might be easier to get those values. That's something to look out for. And then sometimes it is that there's a reason to round off. And so, like with carrots, it's possible that like as you're carving a gemstone or a diamond, as you're shaping it, maybe you try, oh, I'm going to go a little bit below 1.5, so I don't want to do that. So you stop there and stop taking off facets or whatever. That could be something that's happening here. So anytime you see like peaks and then drop off, something either in the measurement or in the process is probably causing people or causing the values to group around those rounded values. It can be really dangerous. Like I early on when I was doing some data analysis of student data, I thought I had a weird pattern going, and I was like, and then it was like, oh no, these assignments tend to be a number of questions such that the values that I'm seeing are the only possible values, and the ones in between are like longer assignments that have, you can get a 94.7% or whatever, like the percentages that seemed to have drop offs. It was just like that's what's possible to get, and so it's the same kind of thing. And that was like one of my first ones where I was like, oh yeah, no, there's nothing here. I thought this was something really weird going on, and it's just this is what's possible. Oh, and then so another thing you can do that he goes into a bit, and I didn't have time to like copy everything in, but he goes through chord Cartesian. There are many ways to zoom in ggplot, but pay attention that chord Cartesian is what he uses, and it's what doesn't break things. So use that. You can also just set X and Y limits, but when you just set the limits, any data that spans over those limits gets dropped. And so it can make things look weird when you do that. Whereas if you do the chord Cartesian, it's literally just like zooming in on a piece of the chord of the plane. All right. He talks about dropping values. Like I think it's good to note that it sometimes it's okay if there's some weird value, like there were values where it's like 100 times the normal value. Depending what you're working with, you might want to just set those to NA, but tell people that you did that. And oh, sorry, going back to the what data to use, data2viz.com is in the chat, and that is a good site for like getting suggestions of data viz. But yeah, so if you drop a value, make sure that whenever you're, pay attention to that, let people know you did that. Don't try to hide it or whatever. But sometimes, especially if you can explain it, or you can kind of explain it, like this value is literally impossible. It has to be a mistake. So you take it out of the data, things like that. Although also sometimes those can be interesting to look into. Like, why is it 1,000 times everything else? Maybe that is the only data you actually care about. But as you're doing other analysis, it can be useful to drop that one value that's crazy. And the reason he did this is he showed that there was one that was like so far of an outlier that it smushes everything else together into one like little point basically, and you can't see the variation. Like imagine if there was one value in this data that was 1,000 carats, all of the real values would just look like one line in your analysis, but that 1,000 carat one is bigger than the Hope diamond, so probably not real. Oops. He had a section on missing values, and I thought it was interesting because he doesn't talk about it much, and it actually kind of goes over what he just talked about a little bit, that when you have a weird value, you can just drop the whole row, or you can replace it with NA, and he recommends replacing it with NA. That's why R has NA, because you can use it to log things that you don't know. Like I said a couple of weeks ago, kind of think of it as I don't know. And so whenever you see NA, it's there letting you and future other people know that this is a value that we just don't know what it is. And so he makes this one where if y is less than 3 or greater than 20, he sets it to NA because those are weird values that you want to get rid of. But you don't just like drop the row, you just say, I don't know the Y for these ones. ggplot2 gives you a warning when you try to plot something that has missing values, and you can suppress that with na.rm equals true in certain, depending on the geometry that you're using. Let's see. And yes, the R graph gallery has some great visualization examples, and the R cookbook. And so the chat for today is going to be full of useful links. And actually, we'll put those into the slides because I have a slide where they would go. All right. So the next thing he talks about is covariation. That's tendency of values of different variables to vary together in some related way. That's a big part of what we're trying to figure out in data, is how do things covary, and how does this variable depend on this one, this other one, or maybe several other ones. And when you visualize it, it depends on, or how you visualize it depends on what's in the pair. And again, I wish I had visualizations in here, but I didn't have a lot of time to put this together. But so the first thing he talks about is categorical and continuous. He shows a geom box plot and kind of goes through that. I'm going to talk about that a little, but I want to talk about this. So this Cedric Shearer does ggplot, or does Tidy Tuesdays pretty much every week, and he's very good at it. He does really cool visualization. He a year or two ago, he was doing all of these while he was getting his PhD, and then got his PhD, and now pretty sure he's working full time doing data viz because he got really into data viz and is very good at it. He makes really pretty plots. And he has this tutorial about what's called rain cloud plots. You can kind of see why these kind of looks like rain clouds. And it's a better way to visualize where you've got these 3 continuous variables, and then you're visualizing the bill ratio of those 3 variables. And so he's grouping all the data into those 3. And for each of the 3, you've got, this is called a density plot, the cloud part. And that's just how much of the value is at, or how much of the total distribution is at each of these values. So you can see the peak for this one is up here, a little over 2.2. But then below that, he's got the box plot, which is the box with the whiskers here. The thick bar on a box plot is the median value. The right end is like the median of the top half of the data. The left end is the median of the bottom half of the data. And then the whiskers extend out 1.5 times the difference between the box, basically, or up to 1.5 times, depending on where the data goes. And then in addition, he just does a scatter plot of the values, where you just jiggle the data around there, or around that line. And so you can see all the actual values. You can kind of see, okay, like this isn't a super great example of why this is so useful, but like when there's a hole, you wouldn't be able to see, like, there could be nothing here and you would still have this same box plot, but you wouldn't know that there's nothing at 2.3. And it can be useful to know that there's nothing at, around 2.3. And so having all 3, like the density plot can show you that. But having all 3 makes it easier to see all of that data. And I'm going to link to it. Oops, but he had, there we go, a tutorial all about all this. Here, I want to get up to his motivation here of, a basic way, a way that a lot of people make these kinds of visualizations is what people call a dynamite plot, where it's a bar plot supposedly with an error bar on it, but the error bar doesn't really show you much of anything. And so this is this same plot, but there's so much more information here. Now you have to know how to read it. Like, It's not necessarily any good for, it depends who you're showing it to, or if you have time to explain to people what is happening here. But there, if you know how to read this, this tells you so much more than this, and you can make it from exactly the same data. Okay, and nothing else came up in chat. All right. So the book only really goes into box plot, and I can't remember. I think he did a couple other things, but he just touches on things, and there are many other options. And so I wanted to point to Cedric's tutorial because he goes into a lot of those options. So again, I should have and we'll hop over to the chapter in a sec, but categorical plus categorical, you can look at just counts. Geom count is basically a grid of how many of each pair of things are there. Geom type, actually, let's just go to the book. So, so that's a geom count. It can be really hard to it's hard to see what the differences are, especially in kind of this area. So that's a little tough. Something like this can be easier to spot, like, okay, that's the high, and all of these are kind of low, and you can kind of see that they all go together. So a geom tile can be useful that way. I don't know what, like, I've struggled with this. I had some stuff like it still can be kind of useful. We had something where I had two different continuous variables that we were, categorical variables, and we were kind of trying to see coverage. And so it was something where we basically wanted this to become useful or useless, where all the dots are about the same size. And what made it useful is some of the dots were tiny or missing. And so that can be useful for that of, oh, we need to focus on those tiny dots. So that can be useful. Again, for the same sort of reason, this could be useful, but actually it's, it's harder to see necessarily the difference between a little and a lot here. And so possibly using something where the color for 0 is drastically different from the color for 1, for example, might be important. All right. Oh, yeah. So we're going to talk a little bit about the way to do ggplot2 calls, but there's a question: what is the difference between putting AES inside geom count rather than inside the main ggplot call? So that one, if you put it inside of the main call, it applies to everything, and you can override it in each individual geom. So for example, you might have I don't have a good example in my head, but you might have two types of curves on the same plot, and for one, like a lot of times this is bad, but if it's on the same scale, maybe y for one of them is one variable, and y for the other curve is the other variable. Like if it's two variables that are varying against one another, that can be useful. And there you would specify y in each of those geom smooth calls or geom point calls. And so that's why you might want to specify it. A lot of times, I feel like if you're specifying it inside of the geom, you're and yeah, supply versus demand, you might do something like that. A lot of times, if you're specifying it inside of the geom, I think you should think about what you're doing, because you're saying for this geom, X means this, and for another geom, X means something else, or whatever, like color, alpha, things like that, maybe. But just be really careful, because it can make for really confusing plots. So as a rule, I try to specify it. I actually, like you might have seen in my code, usually I do it a way that is super weird that no one does, where I put the aesthetic as its own thing, which also works. So you can just say you add the aesthetic and then you add the geoms. I like to do that just because of what I'm talking about. I want it called out. I want it clear that for this plot, X means cut and Y means whatever, and color means this other thing. And so I call it out as its own call. So I'm definitely weird that way, though. I don't know of, or I know of like 2 other people who like to do it that way. All right. So all of this, like the reason we're doing visualization, and I guess just to pause for a second, that um, doing visualization is a very important part of any data analysis that you want to do. Like a lot of times people will kind of want to skip it for certain things, but you can learn so much by just throwing some data onto a plot and seeing what you see. Like I say, doing that grid of 2 continuous variables against one another, and you expect it to be pretty much, oh, this isn't going to really show me anything, and then there's a hole in it, and that hole might become the entire project of, why does that hole exist? We need to fix that, something like that. So it's just, these are very useful to do, and that leads us to when you do find some sort of pattern. I just called out that he had these 5 questions that are very useful. So you should ask yourself, when you find a pattern, could this pattern be due to a coincidence? In other words, could it be random chance? How can you describe the relationship implied by the pattern? So, as X goes up, Y goes up, that kind of thing, or, just trying to put it in really simple terms, or the price of the diamond is directly related to the number of carats of the diamond, or the price of the diamond depends on the cut, or different things like that. A good question to ask yourself is, how strong is the relationship implied by the pattern? And obviously that's something that later you might go into modeling and trying to really determine how important that is. But just looking at it, does it look like it changes a lot? Actually, that leads me to a thing that I don't know if I guess probably more in the ggplot book we would talk about, but there is a tendency that you will see online a lot of, like, let's say we're only looking at these 3. You might start the count at 10,000, and that can be really misleading, because if you imagine, let's say we only had these 2, and our plot went from 10,000 to 15,000, it would look like a much bigger difference than putting it on the whole plot. And especially when you're trying to look at, I don't know, something like this, where there's the counts kind of mean something, you can trick yourself by setting the Y value not to go, or setting either one not to go to 0. So just make sure that you know what you're doing, and like do it intentionally if you are changing the scale to not go to 0, because you can trick yourself into going, oh wow, like those are so different. But then you look at the axis and you go, oh wait, that difference is nothing. Like that range of that difference is no difference at all. So check for that. Another question is, what other variables might affect the relationship? So sometimes you can just, let's say you've got your plot of counts by some variable, and you just add a color of some other variable. And you might see that, oh, wow, those patterns are totally different for the 2 different colors. Or you might facet by another variable so that you pull the plots apart. And so just seeing how those other variables affect the relationship can be really important. And sorry, that's what I beat to the punch of, does the relationship change if you look at individual subgroups of the data? So maybe you want to do a facet wrap by some 3rd variable and pull the plots apart. And when you pull the plots apart, maybe one of them goes up as, X goes up as Y goes up, and maybe another one, X goes down as Y goes up. Or I guess that's vice versa. So it's useful to pull it apart that way. All right. So the next thing that I go into, or I think that was the next part of the book, is simplified ggplot 2. This is the way he has been writing the code, and pulling out what is the data, what is the mapping, and then adding on the geoms. And just going forward in the book, he tends to just say data, mapping, and then the geom. And like I said, I'll even usually just pull this out into its own line. Yeah, John's crazy way. ggplot of faithful with aesthetics of eruptions and geom frequency of blah blah blah. I like to pull that out, and then also it lets the first plus means with, and the second plus means and. In general, I mean, with, they can all be with or they can all be and, but when I read them that way, it tends to make sense. All right. Oh, and so I didn't get anything in here. We can go over to the book about the modeling stuff, but actually they're making a new version of the book where they entirely pull the modeling out and say, go read other books about modeling. But I do want to talk about the modeling stuff. This slide I put in here so that I had a place to put all the things we're going to talk about, or that we are talking about, over in the chat. We'll throw those in here. Oh, and thank you, Susie, that you're with me on the crazy AES. All right, and so factors for colors. So yeah, I don't know if we, so a lot of times, basically when you have a group of, or a set of values, and you want to color by that value, I think ggplot actually yells at you, or it just works weird, looks weird. I can't remember which it is, if you don't specify that that variable is a factor. And the reason, so if you think about it, factor means this variable can only have certain values, and otherwise a character variable could have any value. And so let's say you were trying to color by the person's full name, then everyone would have their own color. It's effectively a continuous variable. Like it's kind of a categorical variable, but each category is size 1. And so that's why, in general, like again, I think ggplot does yell at you if you try to use just a character variable for color or for fill, because of that. It's making you make the decision of, wait, is this actually individual values? And so then then actually, I guess I can go look at these where we did it. It was in here that it doesn't actually yell at it. So cut, I don't think cut in diamonds is a factor. Let me see. Oh, cut is a factor. It's an ordered factor in the data set. So if it hadn't been, you would have to specify, hey, this is a factor, and it's ordered, so it goes from fair to ideal instead of just going alphabetical. And that's another reason to actually specify your factors. You might want to set the order of the levels. Otherwise, it's just going to alphabetize them. All right, and yeah, that you can group inside of aesthetics. A lot of times, like, you can specify groups, but you can also specify groups by setting a color, or a variable that is the color, or a variable that is the fill, that is effectively grouping by that variable. All right, so anything else, or anyone else have anything to talk about before I hop over to the book? Okay, let's go look at that. Patterns and models. So, oh, right. So I called out the questions, but I didn't go into, like, okay, how do we answer these questions? So an initial way to start answering these questions, is digging into more visualizations. Like, okay, like, I think, yeah, what he was talking about here is like, okay, these are separated, but like, how do I quantify how much that is separated? Like, looking at it, I can see I've got kind of 2 clusters, but I've also got a blur in between the clusters. And so he goes into some simple modeling, or not simple, but starting modeling. Like I say, I'm not really prepped to talk about this part, but this is an older package, and so it doesn't hurt to learn the basics through it, or the general idea of modeling through it. But we have the tidy modeling with our book club over in another channel on R4DS, and that one is kind of the new good way, new clean way to build models. All that said, like there's nothing wrong with an LM from base R, and just looking at the residuals, which is like the errors in your, or how much you miss each value by with your model. Yeah, there's a lot going on here, but I'm not ready to talk about it.